Good afternoon and welcome to the 23rd Annual Exhibit of Hydrogen and Fuel Cell Technologies. We're always interested in innovations, things that are being developed, new products, new ways of dealing with the technology, and we'll be talking to a specialist up next on stage with innovations within the fuel cell itself. We'll be talking to Dr. Thorsten Hickmann, who is CEO of Eisenhuth, and we'll be talking about the new gasket bipolar plate materials, but much else coming from Eisenhuth. Please welcome with me Dr. Thorsten Hickmann. So, good afternoon.
Hello.
So this is, of course, not the first time you've been here, but for those who are not in the know, perhaps you could tell us a bit about Eisenhuth, where you're located, what size you are, and what you people do.
Okay, yes. In fact, we are located not very far from here, about 1 hour's drive in the southern part of Niedersachsen, of Lower Saxony, in the Harz Mountain area. And we are a typical SME, small and medium-sized company. And we have 3 business lines. The one is a mold-making business. The other is production of small and medium volume of plastic and rubber parts. And for a couple of years, we're a component supplier for bipolar plates and gaskets.
Now, there are certain people who have core competencies that allow them to work in the fuel cell industry. They simply have things off the shelf, they have ideas, they have abilities to work with certain materials or chemical sciences. So what explains your success story in the fuel cell business? What sort of key core competencies do you have?
Yeah, the key competence is definitely the production of graphite-based bipolar plates and all which is around. That means also the gasket competence and sealing competence, yes.
Now, we are going to get to the bipolar plates, which are here on the table, and they're quite fascinating, but I can't resist mentioning that you recently received an award, the German Sustainability Award, for a unit that operates fuel cells and helps us to deal with wastewater. Could you describe that wonderful award-winning system?
Yeah, the idea is in a wastewater plant you always have a lot of wastewater, and this wastewater has some ingredients as bacteria and microbes. And the idea is that you combine these wastewater together with air. This is not very new because also today you have to use oxygen or air in order to clean the wastewater. But our idea is that we do it in a microbiological fuel cell, and then we can clean the water on the one hand, and secondly, we can create electricity. Yes.
So this is sort of like a self-financing water purification plant because they do require energy.
Yes, and what is not very well known in the public is that the wastewater plant is a kind of big energy user. So depending on size, you have each wastewater plant, they look at how much energy need per inhabitant. And there's a figure somewhere around 50 kilowatt hours. So for a plant which is made for 50,000 inhabitants, you have a lot of electricity which needs to be used in order to clean the water. And the idea is that maybe in the future it will be a zero electricity user. And we're on our way to it.
So that was 50 kilowatt hours per person. Per capita. Yeah. Well, if you multiply that by 89 million people plus...
There's a lot of energy coming out of it, yes.
Okay, so we say that's a shocking amount of electrical energy.
Yeah.
let's move on to the plates. People talk about different plates. Graphite plates have been a standard in many stationary applications. People think of graphite and they think of brittle. I think of my pencil, which is always breaking after I sharpen it. What is so special about your graphite plates?
Well, we have a new product. This is kind of flexible, so you can bend it. So there's no any brittleness anymore. And this opens a complete new field of applications within the fuel cell sector, but also in the general industry sector. Yes?
And when you use them in your stack systems here, I see this is a typical bipolar plate.
Yes.
And you've integrated the gasket into this as part of the manufacturing process?
Yes. The idea is to have not so many components. So you need to, or you have in the system usually hydrogen, oxygen. You have the membranes, you have the bipolar plates, and of course you need the gasket as well. So the idea is to integrate the gasket either, like in this case, on the bipolar plate, or in other cases on other components. Yeah, and we have some ideas how to do it very smart in order not to have too many components and to industrialize this process easily.
The fuel cell industry is always developing, but they're still looking for commercial markets. There's a lot of designing going on and R&D. Some people have some brilliant ideas, and they think all we need is the expertise, the material scientists to help us. Do you help engineers with brilliant ideas go through the R&D process and structure their fuel cells? Do you tailor-make your systems, or is this the size you offer?
No, in fact, we are asking the customer what his desires are, and then we act on it. For that reason, we have mostly tailor-made designs and tailor-made concepts. And if the customer says, I have this and this application, we start looking at the materials and make first the material development, and later on we make the plates. That means the material, the processing development, depending on volume. So for small volume, we have these blank plates or milled plates, and later on can be compression molded or injection molded. Yeah.
And of course, everyone wonders this question. The R&D phase is expensive because you're tailor-making only very few numbers. Your manufacturing capabilities allow you to go to larger volumes very easily?
Yes, since we also have realized the injection molding process, this is state-of-the-art for high-volume production for plastic parts. And we have this technology of plastic part production also in our company. We know how to do it, and automatization is also no problem to it. Yeah.
And how easy is it for you with your processes to create different sizes for the bipolar plates?
To a certain extent, that means to a certain size, it is no problem. The customer says what size he wants, and we deliver it. Yeah, at least to, let's say, standard sizes like this size or that size, 500 by 500 millimeters.
And in terms of manufacturing capacity, we know it's a relatively small industry here, but you can certainly produce large numbers. I think large numbers are still relatively small, but if someone comes with an order for 5,000 or 10,000 bipolar plates, it's manageable?
Well, 5,000 or 10,000 plates is reality in our factory for certain customers. Not too many, but yes. And well, the idea is to join the scale-up process in order to go to higher volumes. Yes.
There's, of course, very complicated electrochemistry involved, but some people think not only of the size, but the thickness of the bipolar plates. Do you offer variations?
Well, the customer says what thickness he wants, and then he gets his thickness to a certain extent. So we are not in competition with metal bipolar plates where the thicknesses are just around 0.1, 0.2 millimeters. But apart from 0.5 or 1 millimeters, we can go to 1 to 3 millimeters, or also very thick plates. We have customers who have 2 centimeters of thick plates, no problem.
So where sizes are issues, for instance, sometimes in mobile applications, they may have a different precedent, but for stationary applications, this is entirely viable.
Yes, especially in the field when you have long lasting issue, that means long operation of the plates or the systems on the one hand, or you have a very aggressive atmosphere. That means a lot of acids in there. Yeah, we are one of the component suppliers for high temperature PEM fuel cells. There you have phosphor acid, and that's a good way to use graphite in this field.
So they do a better job, the high temperature PEM cells, of dealing with things that otherwise would cause degradation of the cell.
Yes, definitely. Yeah.
So there's an advantage. There's an advantage to graphite. Of course, you don't only do award-winning technology in the field of water processing and graphite bipolar plates that are flexible. There's another product that you have, which I found fascinating, new titanium-based bipolar plates for electrolyzers.
Yes, for PEM electrolyzers, that's true.
Could you describe that for a minute?
Well, the idea is pretty simple. Now we have a mixture of plastic and graphite in this case, but we can replace the graphite with titanium powder. And then we have all the design freedom and processing freedom as we have now with the graphite plates. And there's also a market for this, which can customize the bipolar plates in this field, yes.
We've seen at the Hanover Fair the market for electrolysis has been booming. The businesses are doing well. The number of stands here that deal in electrolysis has increased dramatically. It's just a booming business. So do you see large prospects for your titanium-based bipolar plates for electrolyzers?
To a certain extent, yes. I mean, the existing actors, they have a certain design, and now it's our job to convince them to maybe rethink their design and go new ways. But we're in a good way, yes.
I should add, if there is a question from the audience, we do have time for a question or two. I certainly have a few questions remaining. One of them is related to the market prospects for the next 3 to 5 years. How do you see the market developing from your perspective?
Well, at the moment we have the situation that due to the discussion of electromobility and due to the discussion of having energy storage systems all over in Germany and in Europe, that there's ongoing demand on components, on fuel cells, electrolyzers, redox flow batteries. So we are pretty confident for the next couple of years it's going on, but it is not like an exploding business. It's going slowly by slowly, but in a good direction, yes.
Do you see the industry as also in part policy driven? What I mean by that is I come from Berlin, and several times a year we have these theoretically European alarms. That is, the quantity of air pollution from traffic is so high that they actually should stop the traffic, and there's a big debate about whether they're going to block diesel traffic. That is, there is a real fundamental issue of how we're going to change mobility within our cities. Do you see that as a potential driver for the market of your technologies?
Yes, of course, because all the people who are very seriously engaged in this issue know that electricity for the cars exists, but if the number of cars increase very strongly, then we have a problem with getting the electricity to the cars. So they have to think about range extender solutions, and one of the solutions definitely is a fuel cell. We see the fuel cell car of Daimler-Benz here, and the other companies are very strongly engaged in this issue. And this is not only an issue in Germany, but it is also in Asia, where a lot of action is going on fuel cell cars and fuel cell buses and fuel cell trucks. So we have to keep an eye on it to join this process. No?
And of course, the other technology provides another entrance discussion about energy storage and energy self-sufficiency. Germany imports massive quantities of energy, natural gas, for example, but we're not doing a good job of harvesting renewable energy from the North Sea. That is, we are still turning wind turbines off. Energy curtailing is the expression some people use. I find it deceptively rhetorically ingenuous. We're turning things off, power that is potentially harvestable, because we can't store it. This leads to the question, do you see any alternative for large-scale energy storage without electrolysis?
Yes, definitely a good additional option in this medium and high volume energy storage system are the redox flow batteries. And in fact, there are a lot of actors and companies also in Europe who are working strongly on this field in order to provide to a higher hundreds of kilowatt or even megawatt scale in order to get this energy at the right time, at the right place. Yeah.
So you're part of the chain.
We try to do our best, yes.
Well, that's a very humble take on your great achievement here. I begin with the water plant simply because this is a massive quantity of, a shocking quantity of electrical energy that you're saving, making our water clean using clean energy. What could be better? The best of both worlds. I have been talking to Dr. Thorsten Hickmann, who is CEO of Eisenhuth, about the new gasket and bipolar plate materials, but much more. This discussion should continue, so do visit Thorsten Hickmann at his booth, which is D53 in this direction. Yeah. It's been a pleasure talking to you, Thorsten. I hope to see you back here next year.
Yeah, thank you. It was a pleasure also for me. Thank you.
Thank you. And thank you. There will be a short pause, but we'll be back here at 4 o'clock for Dr. Michael Walker, who is from DVGV, depending on if you do that German or English. It's the German Gas and Water Association, and they'll be talking about the role of hydrogen in the energy system, a very related topic. Sit down, have a drink there on the house, and I'll see you at 4 p.m.